The recent rise in popularity and accessibility of generative AI systems, including large language models, image and video generation models, and audio generation models, risks outpacing our understanding of these systems' potential risks and societal impacts. These tools are widely deployed across various domains such as AI chatbots for customer service, generative protein folding models for AI-assisted drug discovery, AI-powered tutoring systems for personalized learning experiences, and AI coding assistants for software engineering. These tools already affect millions of lives daily, and we face a critical challenge. How can we identify and mitigate the unforeseen vulnerabilities and harmful behaviors of these complex systems? This gap in our knowledge has led to the emergence of a crucial practice in the AI industry known as red teaming. Adapted from military and cybersecurity contexts, red teaming has become an essential tool for AI developers and researchers seeking to probe the limitations and potential dangers of their creations. In this video, we'll explore what red teaming means in the context of generative AI, its importance and limitations, and how it's being implemented to help ensure the safety and reliability of these powerful AI systems. Red teaming in the context of generative AI entails any structured testing effort to find flaws and vulnerabilities in an AI system, often conducted in a controlled environment and in collaboration with AI developers. The term red team originates from military exercises, where a group would play the role of adversaries to test defenses. In AI, red teaming adopts a similar adversarial approach to identify potential risks and weaknesses in AI models. However, it's important to note that there's currently no consensus on a precise definition of AI red teaming. This lack of clarity has led to variations in practices and expectations across the industry. It is important to understand how generative machine learning models differ from more traditional, discriminative machine learning models. Generative models create diverse outputs that are open-ended and less predictable, which makes it harder to anticipate all potential harmful scenarios. In contrast, discriminative models usually categorize or predict within a constrained set of options, which makes their risk surface smaller and easier to evaluate through standard performance metrics and benchmarks. In addition to this vast space of possible outputs, there are a number of other reasons red teaming is so crucial for generative AI. These include the listed items that will be discussed further. Widespread application. AI models are being deployed across various domains, affecting millions of lives daily. Limitations of traditional benchmarks. Existing performance metrics often fall short in measuring real-world impact and potential risks. The wide range of possible outputs, uses, and misuses makes it very difficult to design comprehensive benchmarks. Need for specialized expertise. Evaluating AI systems requires domain knowledge to assess potential unsafe behaviors effectively. For example, assessing the risk that a model facilitates the production of dangerous biochemical materials requires biochemical experts to assess model outputs. Real-time and dynamic attack surface. Generative AI is increasingly deployed in real-time applications such as chatbots, where outputs directly influence users and decision-making processes. Moreover, generative models interact with users more dynamically, making them more susceptible to adaptive attacks such as prompt injection, jailbreaking, and adversarial prompting. Red teaming ensures that models maintain safety and ethical standards in these fast-paced environments by testing responses under diverse high-pressure scenarios. It also helps identify vulnerabilities that could be exploited through conversational tricks or subtle prompt modifications. Anticipating adversarial use. Understanding how bad actors might exploit these systems is crucial for developing robust safeguards. Generative AI can be exploited for a wide range of malicious purposes, such as generating disinformation or offensive content. Ethical considerations. Generative AI often deals with more nuanced ethical issues. Red teaming allows for testing how these models behave in ethically challenging situations by simulating diverse real-world interactions. Red teaming helps identify potential biases and harmful outputs that could have severe societal implications. The effectiveness of Gen AI red teaming efforts depends on a number of factors. These include diverse team composition. Red teams may include internal experts, external specialists, and even crowdsourced participants with very different backgrounds and areas of expertise. Varied approaches. Some exercises focus on specific vulnerabilities, while others take a broader, exploratory approach. Different stages. Red teaming can occur during development, before public release, or as an ongoing process post-deployment. Multiple techniques. Teams might use manual probing, automated tools, or even AI-assisted methods to test systems. Resource allocation. The time, compute power, and expertise devoted to red teaming can vary significantly between organizations and is closely related to evaluation team composition. Despite its importance, red teaming faces several challenges. Lack of standardization. There's no universal framework for conducting or reporting the results of red teaming exercises. Resource intensive. Thorough red teaming requires significant time, expertise, and computational resources. Incomplete coverage. It's impossible to anticipate every potential risk or misuse scenario. Balancing disclosure. Companies must weigh the benefits of transparency against the risk of exposing vulnerabilities. Keeping pace with AI advancements. As AI technology rapidly evolves, red teaming practices must continuously adapt to emerging capabilities. Stochastic and dynamic nature of model outputs. Model outputs often vary significantly for identical prompts and can evolve over time through interactions with evaluators. As we've seen, red teaming plays a vital role in ensuring the safety and reliability of generative AI systems. However, there's still much work to be done in standardizing practices, improving transparency, and addressing the challenges we've discussed. Moving forward, collaboration between AI developers, policymakers, and diverse stakeholders will be crucial in establishing robust red teaming frameworks. This will help us harness the potential of generative AI while mitigating its risks.